Beginning transmission now. This is the Chaos Community Broadcast, a show about failures and how to navigate socio-technical complex systems so you can surf the chaos without failure. For recording of this broadcast, as well as all of our previous broadcasts, type in chaos.community into a web browser of your choice. I am your host, James Wickett.
And I am your other host, Casey Rosenthal.
Well, today we are live at GOTOpia 2021 Chaos Engineering Day with a live Chaos Community broadcast with a host of guests, some of which have been on the show before, you might be familiar with, and some new. Welcome Adrian Hornsby, Crystal Hirschhorn, and Miko Pawlowski. Crystal Hirschhorn is the current director of engineering at SNCC, overseeing cloud native infrastructure platforms and SRE and cloud security. Welcome, Crystal.
Thank you. Thanks for having me.
Adrian is a principal technical evangelist at Amazon Web Services and is based in the Nordics. Adrian, glad to have you on the show.
Hi, thanks for having me.
And Miko is the author of The Chaos Engineering Site Reliability Through Controlled Disruption. He works as an engineering lead at Bloomberg, building a platform based on Kubernetes. Miko, thanks for the show. Casey, you're here as well.
Yes, I am. And if I could just point out, I believe I'm the victim of a miscommunication. As you can see, I'm here in CodeNode. James, you told me that it was going to be in London at CodeNode, so I got on a plane, came here to London, and I'm in CodeNode, and nobody else is here. So...
yeah, we've been through this before, Casey. All events are virtual now. That's how it works. It's just virtual.
Virtual. Are you virtual, James?
Okay. Thanks. Yeah. Well, for our guests on the show, we are glad you're here. Maybe we can start off with a softball question for everybody. Each of you have seen chaos engineering get adopted at organizations of all sorts of scale, mostly large. Please tell me what the benefits that you've seen of chaos engineering when it's done right, when the clouds part and there's this moment of clarity and seeing what you've done or what's been accomplished by the team there. What are those benefits you see that kind of ripple across the organization?
The biggest thing is we know that failures will happen, incidents will happen. We'll never eradicate that from our systems, nor should that be a goal. But the cool thing to see was to see people go from a place of being really scared and fearful of being on call, and to kind of take true ownership of their systems, to kind of being in a place where they actively wanted to own that and weren't scared to be on the on-call rota, essentially.
Yeah, I'll echo that as well. I think for me, the biggest transformation I've seen, both from my previous companies and with the customers I've worked, is really cultural transformation where the teams, the people, and the company feels confident, with maintaining building, maintaining, and trying to fix their systems. As I said, for me, the biggest problem with outages is if you are unprepared, it's a very, very scary experience, right, for anyone. And I really, it's not a situation that we want anyone to be. So I think chaos engineering is great for that. And it has some, effects to the whole company. I think it promotes, discussion, it promotes transparency, and I think that's, those benefits kind of reverberate to the entire company. I think that for me, that's really the benefit.
Yeah, that also resonates with my experience. And I think just to kind of complement that, I think from my perspective, the most underappreciated aspect of that is, what you mentioned is that the kind of making the rota less scary, but also kind of forcing people to think with the failure in mind from the beginning. It's not that we can get away with that, but we know that there is going to be some verification of this kind for the failures. So you kind of have to build that. And, I might be coming a bit more from the platform point of view, where, other people's code is running on the platform that I maintain. So I can kind of enforce that kind of thing. But just a, change in mentality that, it's not a maybe, they made sure that it's going to fail in this kind of ways, was a big kind of methodological change, and I think that's a lot of value just from that.
I noticed, Miko, that you did not answer that the biggest advantage to come out of chaos engineering was a book deal. If I could change that question slightly, what's the oddest thing you've seen come out of chaos engineering? Besides the practice itself, one of the early stories that sticks with me from Google's DIRT program, their disaster and resilience testing program, their equivalent to chaos engineering, is that they ran an experiment where they turned off power to one of their buildings on Google's campus, and then had to deal with repercussions such as the ice cream in their freezer melted and created a giant mess in their kitchen, right? Unanticipated systemic outcomes of fault injection. Do you have any stories along those lines?
I quickly mentioned something around latent defects when we do a chaos experiment. I think one is one day we took down our response system by trying to inject failure, and we found out there was a dependency, and the whole response system, escalation, paging all started to fail. So actually which was something no one expected. So, and these happen a lot more often than we anticipate. I think, having weird dependencies that we don't think of, I think it's quite common.
One of the early things that I saw that was probably unanticipated was more on a people matter, which was trying to shift the culture away from blame. So our very first theory crafting session I did at my previous role, when we were kind of taking part and kind of playing different parts in that session, one of the kind of scenarios was that, oh no, there's now, one of our biggest images, our hero image on our homepage is gone. It's actually showing an error to end users, and it was kind of like, what do we do next? And somebody actually shouted out, we should fire them. We should fire that engineer. And I was like, no. No one's getting fired. Like, it's just something that happened.
If you didn't fire that employee, how did you punish them?
Great question. I told them this will never happen again.
Have you tried post notes, this person caused this, to wear for a couple of days?
What, like a dunce cap?
Hat,
That they have to wear on. They have to wear around the offices. Yeah, no. Blameless culture, people. Blameless culture.
A 3-armed sweater, but a 0-armed sweater instead, but they actually have to fit it on.
I think it's also worth mentioning that, I've definitely seen, at least in my experience, kind of bottom-up approach where the actual engineers started with that. And sure, the name doesn't help, and we're kind of still fighting against that, and there's plenty of sales that you need to do to your higher ups. But at the end of the day, if this is something that the teams see as a worthy investment of their time and something that reduces the number of problems, or at least helps them discover the problems during working hours, I think that whoever needs to okay that, these are good arguments for that. And then there's obviously the kind of other aspect of selling that, and kind of the hamburger versus shark problem, where people are scared of sharks but hamburgers kill them more, and stuff like that. And there's a little bit of art to sell these things, but I wouldn't discount the bottom-up approach. From my experience, that's how it all started.
Mm.
I'm curious to hear more about these killer hamburgers. But one of the reasons I think we're still talking about chaos engineering, despite, as I think all three of you said, the unfortunate name, is that unfortunately it provides value, right? Like when the successful chaos engineering programs that we have all run have shown good results. What could we do to undermine that? How could we put this to bed so that we can go on to thought lead about something else?
Embed it in systems and go to bed.
That's your job, right, Adrian? Is that embedding it into systems? And
Yeah, I mean, that's what we're trying to do, right? I think make services frictionless for our customers and make the discipline frictionless. I think a lot of problem with the discipline is is currently the friction of it. So it's very hard. It's a steep curve to get started with, and it's scary, and it's a lot of tools, and I think it's a lot of it's not easy. It's not easy. So I think if we can make that easier, for everyone everywhere, then and then we can go to bed.
I think it's all about making it boring. If we make chaos engineering boring, we can move on to something next. So that's really what it is. And like you said, the name doesn't help. It still sounds exciting, but eventually people will get bored of it. Looking forward to that.
I think we should just automate it all and then move on.
automate it all, because nothing ever goes wrong with automation. Yeah. I like the idea of making it boring. James, I'm sure you're a big fan of that. Do you have any additional questions, James?
I can see how you would like that. We did have a question from the audience that came in. Casey, during your talk at GOTOpia, you presented some thought-provoking myths. And one of the, I'll just read the question asker's words here. They said, "I must admit that I got a bit provoked by the statement that simplify as a means to get a more robust system is a myth." Can you comment on that?
Yeah, that's a great point. Would any of the three of you like to make that argument for Casey?
Any one of you like to do my job for me, please?
This sounds really familiar, Miko.
I guess on the point of simplify to make something more robust.
Specifically, the point that simplifying does not make a system more reliable.
I mean, I guess one of the key things is, even if you're simplifying something, complexity still needs to live somewhere, and it still exists. And it kind of feels like a nice story. I think Casey, you said this as well, a nice story to tell ourselves, but it's not actually true. And we, as humans, have to be very cognizant of a lot of biases and fallacies. Like there's a lot of hindsight bias and other types of bias that come into the equation. But yeah, I mean, we should know that intrinsically, having been engineers and building systems, that just because it's simple doesn't mean it will never break. Of course it does.
I should.
Simplicity is abstracted, right, from something, and so
that's a good point.
If you make a simple framework, there's something complex under the hood that can fail, right? So it's just an abstraction. It might be simple for you, but somewhere else the complexity is gonna come out. So.
And I should note that the question asker also had a clarifying question that they sort of differentiate between accidental complexity and inherent complexity, and so removing some of the accidental complexity is could be seen as good ways to improve the system.
Oh, sure. So So there's so there's accidental complexity and essential complexity, right? And essential complexity is the kind that we add on purpose. So let's set that aside for a second. So the thinking then would go, okay, well, for accidental complexity, maybe we remove some of that, make the system simpler. The problem with that is there's no known sustainable process for reducing accidental complexity and keeping up with your job. So accidental complexity is the kind of complexity that happens just by writing code. It's like it's like dirt on the floor in your house, James. Like, I assume you don't put it there on purpose. It just kind of accumulates, and so, you know, even if you focus on practices from the craftspeople world of TDD and pair programming, you know, all of the best practices from that realm, you are still, through the process of creating software, going to add accidental complexity. And if you stop and reduce it, you can do that, but that's not a sustainable software engineering practice. So in a sustainable software engineering practice where you are maintaining or building features, as most of us are paid to do, that accidental complexity will always increase. So you can just kind of set aside even the possibility of having a process that would over time sustainably reduce accidental complexity. The same is true of essential complexity, because you know you're being told to add that kind. So regardless of what you're trying to do, the complexity is going to increase. Specifically focusing on the safety of a system, though, we can demonstrate this with a Gedanken experiment, right? A thought experiment. Imagine you have the simplest database you can imagine, key value store in memory, running on your laptop, right? Like, super simple. And the business comes to you and says, okay, make that more available. All right. Persist the data, right? So that when you close the laptop lid, you don't lose data. Put it in the cloud. Distribute the data to multiple nodes, shard it, or put it behind consistent hashes so that you've got multiple nodes with data. Replicate those nodes to different regions, right? Now you've got, you know, by AWS's old paper, a 5.9 plus highly available system, and in less than 30 seconds I described some very well-known industry processes for making that system more available, right? More reliable, more safe. Go back to the simple one of running on your laptop. Now imagine business says, okay, make the system more available, safer, and also simpler. You can't, right? So in order to make a system safer, you are going to have to add complexity.
Which still isn't a license to go and over-engineer everything.
Yes, and so that's the counter that I often get is like, well, you shouldn't add complexity for its own sake, but that's true for anything. You can take the word complexity out of there and add, you know, you shouldn't make something polka dot for its own sake. Well, of course, that's kind of a truism, but I don't think anybody's making the argument that you should run rampant with complexity in your software.
I think when we talk about Blameless, we have to talk about two things, though, which is like surfacing learnings and making, there's still some amount of accountability, and that, you know, again, folks like John Allspaw talk about that quite a lot in the things that they write. But we also have to, you know, try and dig around the psychologies of you know, why these things happen. And how do humans, like as Adrian was saying there, around different types of internal pressures that lead to these kind of events happening. There's also a spectrum which we haven't really talked about, which is like you have the practitioners at the sharp end, and there's kind of a gradient away from that as you kind of get away from the work is done to kind of more work is imagined through management, all the way outside to externally, in terms of who actually sets the legislation, the kind of policies that are then put onto your company as well. And I think we have to think about that too. Like, there's the practitioners at the sharp end. You're right, they're trying to come to work, do their job well. It's extremely rare that somebody is a bad actor in the system. Extremely rare. I have seen it happen a couple of times, but that's usually because there were plenty of signals that we missed along the way to kind of rectify that situation. We've got a disgruntled employee.
You worked with Casey before, is that right, Crystal?
I was trying not to name him
okay.
specifically, but yeah.
Bad actors, she said. I am not an actor.
Well stated. Does anybody else, any audience members have any additional questions for our guests? We have one more I'd love everybody to take a run at quickly here. One of the things people say often is that their organization is not mature enough to do chaos engineering. We've had several of y'all have already spoken throughout the day, and more to come this afternoon. And I'd like to just touch on this at the organizations you've been at, or as people kind of say that to you, is we don't have the maturity level to do chaos engineering. Could you fill us in, like how you respond to people that are dealing with that?
Every organization is mature enough. The problem is that they misunderstand often that chaos engineering with doing chaos engineering in production. Simply the process of doing an hypothesis and getting everyone in the room and talk about what could possibly go wrong, is chaos engineering, is the first phase of, trying to discuss and trying to set up an hypothesis. And very often, if you do it right, it means if you take into account that some people talk louder than the others, and you ask everyone to write on a paper instead of talking out loud, so that you get everyone in the room to voice their opinion, and you ask them what happened if you take the database down, then you'll realize everyone has very different stories. And right from there, you don't need to inject faults. And you can stop there and just trying to discuss what happened, why did we understand the system so differently? Of course, the mental models of systems from everyone is very, very different, but it's important to discuss it because it surfaces maybe some problems in the processes, some problems in the tools, some lack of understanding of the specifications, and everyone is mature to have discussions, right? So I think the problem is maturity of injecting fault in production. Yeah, not everyone, but everyone can start, discussing, and I think that's the important part.
That's pretty much from my experience. Pretty much everybody who says that, they're a little bit intimidated because they feel like they should be all jumping, into doing experiments in production. They also should run off everything in the cloud, and they're like feel a little bit intimidated because they still have a bit that doesn't run in AWS. And sorry, Adrian, it's okay to not run everything in AWS. And once you talk to them, they typically feel much better afterwards. So yeah, I 100% agree with that.
Well, this has been a really great time for us to have the live episode of the Chaos Community Broadcast for the GOTOpia 2021 edition. I'd like to thank all of our guests for being here. Crystal, Adrian, Miko, it's wonderful to have you. Our wonderful audience. Casey, I hope your flight back from London goes okay. I can't believe this happened again. And we'd just like to say thank you to everybody who's watching. This has been an episode of the Chaos Community Broadcast, which you can see in a web browser of your choice by typing in chaos.community. We're ending transmission now.